In this video, we learn about sequences. A sequence is a list of numbers written in a definite order. Sequences in this section are infinite, and the starting index may not always be at 1. So we can start the index from 2, 3, 4, and so on. Here are some examples of sequences. With example 1, we have the sequence defined to be an with n starting at 1 and ending at infinity. So the terms are a1, a2, and so on. So when n is equal to 1, we are going to have a1. When n is equal to 2, you're going to have a2, and so on. With our second example, we have this sequence defined to be n on n plus 1, with n starting at 1 to infinity. So when n is equal to 1, we are going to have 1 on 1 plus 1, which is 2. So that will be 1 on 2. When n is 2, you're going to have 2 on 2 plus 1. So that will give us 2 on 3, and so on. With the third example, we have the sequence defined just as the list of numbers, right? So here we don't have the nth term given here. So we have the sequence to be 1 on 4, 2 on 9, 3 on 16, and so on. Example 1. Determine the nth term of the following sequence. So we have sequence 1, sequence 2, and sequence 3. That's what will be the nth term. With 1, we want the index 1 to have a value of 3 and index 2 to have a value of 4, and so on. So that's when n is equal to 1, we want this guy to be 3. When n is equal to 2, we want 4. When n is equal to 3, we want 5, and so on. So that's an will be giving us, when n is equal to 1, we have 3. When n is equal to 2, we have 4. So then we're going to have n plus 2, right? Now let's see if this is true. So we have an to be n plus 2. That's when n is equal to 1, we are going to have 1 plus 2, which is 3. And that's the first term here. When n is equal to 2, you're going to have 2 plus 2, which is 4. So when n is equal to 3, we're going to have 3 plus 2, which is 5. So that's correct. And so the sequence will be giving us an starting from 1 to infinity. And this is equal to n plus 2, n starting from 1 to infinity. Thus, the nth term is an is equal to n plus 2. With 2, we want the first term to be equal to 0, and the second term, that's n is equal to 2, to be 2, and n is equal to 3 to be 4, and so on. Let's compute n. To compute n, let's look at something. So now all these guys are even, right? So when n is 1, we have 0. When n is 2, we have 2. When n is 3, we have 4, and so on. So now for even numbers, then 2n should come into mind, right? For n is equal to 1, we want the term to be 0. So although we have the even numbers in mind, we should get something that's going to decrease the terms, right? So when we choose 2n, then when n is equal to 1, then here is going to be 2, but we want this guy to be 0. Now for 2n, when n is equal to 2, this is going to be 4. So that's, we must subtract 2 from 2n. And so an will be giving us 2n minus 2. Now let's verify if this is correct. So for n is equal to 1, we are going to have a1 to be equal to 2 times 1 minus 2, which is 0. So that's correct. Now for n is equal to 2, that's going to give us 2 times 2 minus 2, and that will be 4 minus 2, which is equal to 2. And so that's correct. So an is giving us 2n minus 2. With 3, we want when n is equal to 1, the term to be 1 on 4. And when n is equal to 2, we want it to be 2 on 9, and so on. Right. Now let's look at the numerators. So for the numerators, we have it to be 1, 2, 3, 4. So that would just be n, right? So for the numerators, we're going to have an to be equal to n divided by, how do we find the denominator? For the denominators, we have 4, 9, 16, 125, and so on, right? Then squares should come into mind, right? Because 4 is 2 squared, 9 is 3 squared, and so on. Now for 4, we have n to be equal to 1, right? So we know that 2 squared is equal to 4. And we have n to be 1. So that means n plus 1, that will 1 plus 1, which is 2. So that means 2 squared is going to give us this guy. And here we have n to be equal to 2. And 2 plus 1 is 3. And 3 squared is going to give us 9. So then the denominator is going to be n plus 1 all squared. Thus, the nth term is an is equal to n on n plus 1 all squared. Example 2. Suppose that the nth term of a sequence is an, which is equal to minus 1 exponents n minus 1, then n plus 2, all divided by 5 exponents n. And we are being asked to find the first four terms of this sequence. Here, we are being asked to compute a1, a2, a3, and a4, right? So now let's compute these guys and see what we're going to have. Let's compute a1. Thus, we are going to substitute in 1 in place of n. And so this expression is going to be minus 1, then 1 minus 1 times 1 plus 2 divided by 5 exponent 1 is equal to 1 minus 1 is 0. So that was going to give us minus 1 exponent 0, which is 1, then 3 exponent 5. So that's, we are going to have our results to be 3 exponent 5. Now for n is equal to 2, we are going to have minus 1, 2 minus 1, then 2 plus 2 on 5 exponent 2, right? Because n is equal to 2. So you're going to have minus 1 exponent 1, then 4 on 25, which is going to give us minus 4 on 25, right? Now for n is equal to 3, we're going to have minus 1, then 3 minus 1 times 3 plus 2 on 5 exponent 3. And that will be minus 1 squared, then 5 on 5 exponent 3. And is equal to minus 1 squared is 1, so that's going to give us 1 on 25. For a4, we are going to have minus 1, then 4 minus 1 times 4 plus 2 on 5 exponent 4. And this is going to give us minus 1 exponent 3, then 6, 5 exponent 4. So minus 1 exponent 3 is minus 1, so that's going to give us minus 6 on 5 exponent 4. So these are the first four terms of the above sequence. With example 3, suppose that the nth term of a sequence is an is equal to 5, 1/2 all exponents n, and we have to find a0, a1, a2 up to a4. So here n is starting at 0, right? So we need to start at 0. And so let's compute a0. For a0, n is equal to 0, right? So that's going to give us 5, 1 on 2 exponent 0, and this is equal to 5. 1/2 exponent 0 is 1, so that'll be 5 times 1, which is just 5. Now let's compute a1. That's n is equal to 1, so we're going to have 5, 1/2 exponent 1, and this is going to give us 5 on 2. For a2, n is equal to 2, so that will be 5, 1/2 all exponent 2, so that's going to give us 5 on 4. For a3, we have n to be equal to 3, so that will be 5, 1/2 exponent 3. That's going to give us 5. 2 exponent 3 is equal to 8. And for a4, we are going to have 5 multiplying 1 on 2 exponent 4, which is going to give us 5 on 16. And so these are the first 5 terms of the above sequence. Thank you for watching. See you guys in the next video. Bye.